Thank you, Angun. I'm Hui Zhang from UC-Berkeley. Thank you for giving me this opportunity to present this study. My presentation will mainly focus on one of the systems that Angun listed. It's about footwarmers. So one important benefit of the PECS system is that it provides the individual comfort, allowing the ambient temperature set point to be extended. So this slides quantify the energy benefit when extending the set point. In both sides of heating and cooling, 1 degree C of the set point increasing is associated with about, on average, 10% energy saving. So that's a very important energy saving of the HVAC systems. That's a very important number we can remember. And my presentation, the first part is about some of the human perceptions. This study I did for my thesis. I supplied cooling and heating to every single body part of the 16 individual body parts, like back, chest, hand, legs, foot. And the scales that I used is to evaluate their perception of on thermal comfort are 2 scales. One is the left, show on the left hand thermal sensation from very cold to very hot. And the right hand side figure shows the comfort scale is from top part is comfortable and the bottom half is uncomfortable from different levels of comfortable. So in this study, this shows in a uniform cool environment, shows different body parts actually they feel differently. You can see the left, the further left is the whole body, other part is the breathing zone, head, neck, until the leg and the arm on the right hand side. The middle is the foot and the hand. The Y is the thermal sensation. So you can see in cool environment, although the environment is uniform, but different body parts actually they feel different. Hands and foot, they feel most coldest, and then the head region actually feel less cold sensation. But you can see the whole body actually follows the hand and feet thermal sensation. So in a way, this in cold environment, hand and feet cold sensation dictate the whole body cold thermal sensation. If you look at the comfort, this is represented by the green line. The comfort is also the most discomfort are heart and is foot and hand, and the overall comfort, whole body comfort is also dictated by those local most discomforted body part was hand and feet. So in the warm environment, the story is different. This is also in a warm ambient uniform environment. However, the different body parts also feel different. The stories are different. Head region feels the most warmer. The Y is again is the thermal sensation from here is from neutral to 3 means warm. So you can see face and head, they feel warmer than the other body part, and the whole body again follows the head's warm thermal sensation. And the comfort shows the similar trends as the cold condition. Head and face has the lowest discomfort, is the most discomfort presented by the green lines, and the whole body again follows the head discomfort, warm discomfort. So the reason I'm interested at a lot of physiology and interesting thing is animal, this head prefer cooling is across species. In any animal world, you know, like a camel and a deer, they run. When they run, they create the camel doesn't run. It's just the camel in the heat, walking in the desert, create heat in the muscle. When the animal running like a dog, and those animals, when they run, they create a lot of heat from muscle. So if those heat dump into the brain, into their head, into their brain, that will not be good. So the animal created this, built with this countercurrent blood vessels between arteries and veins is called reeds. So you can often run if you have a dog. When dogs run, they put their tongue out, evaporative cooling to cool the artery blood. And by this great countercurrent heat exchange, the cool blood is transferred from the vein to the artery. So when the artery blood reaches to the brain, it's already several degrees, 3 degrees can be lower than the other body part. So that's the protection for their, in the animal world, how to protect their cool brain, cool. And for human beings, when we are hot, we don't pull our tongue out. But we also equipped with most of the heating, sweating gland in the forehead part. So here I listed some of the studies. All the studies like ongoing, I have the references, so people interested, they can to see more details. So based on those studies, we developed this combination. It's the fan and foot warmer combination. It's shown in one of Angong's slides. We use a fan, very efficient, with 4 watts to cool head, and then we use a foot warmer to warm their feet. So right now, there are other companies like a warmer in Denmark. They are making commercial products for hand warming is coming. So in our lab, we have our high schoolers come to the lab. We built 108 foot warmers. It's a great learning curve, learning experience for the high school people. This is happening in our lab. You can see at the corner of the lower right hand side, lower corner, it's also a leg warmer. It's similar to the one Angung showed, the flexible heating element. And we did the field study in a campus library. So it was we installed the kind of foot warmer and the system. Basically, they're a combined system in the buildings, and over months period, we lowered their set point gradually, and then 2.5 degrees, and then come up gradually. We monitored their energy uses. We also continuously surveyed their energy, their satisfaction. So overall, the energy saving is about 30% on the HVAC. So this is the individual value. You can see the heating and the reheating by this dark blue and light blue color was the main part at the bottom 2 bars. And then was the computer, and the top light blue, the sky blue color is the energy used by foot warmer. So this is all measured, monitored energy. You can see it doesn't take compare with other components. It really use a small amount of energy. So now I'm going to describe in a more detailed scale. The study was this is about heated insole. The study was studied by a project was funded by DOE. I was planning to develop a heated insole. When I try to apply heating, I realize my feet doesn't, most of my feet doesn't feel the heating. So then if they don't feel the heating, you don't need to apply heating there to save more energy, right? So I ended using the small things, this is a physitemp stimulus applied to many body many parts of the feet and hand. And indeed, you can see in the feet, this is the mapping of the sensitivity. In the feet, on the arch area and a little bit on the bottom of the toe has the feeling. So based on those study sensitivity, I developed insole. This insole was a special type of insole. Is a little bit has a room in the shoes. So you can, I applied in the arch area and the toe area, total only use 1.2 watts. You can see the lab study on the left hand side, the lab study is you can warm the feet about equivalent to 7 degrees C from change from slightly cool to slightly warm. So the last part of my presentation is about alliesthesia. So that's fundamentally from one area explain why PECS works from a thermal perception point of the view. Alliesthesia was first proposed by Canadian physiologist and psychologist Cabanac. He mentioned that when you are warm or cool, when applying external stimulus to make them towards neutral, people have a pleasure sensation. His experiment is this one. It's when you have a hypothermic, feel cold, or hyperthermia, feel warm. Let's say feel cold. You put the hands in a warm buckets. This is the X means hand stimulus temperature. The Y shows a pleasant sensation. It's very pleasurable. So when you are similar, when you feel hot, put a hand in a cool bucket of water, the pleasure was increased. And later on, Mover repeated study by Cabanac and shows a similar result, but he added one more condition was when people don't feel warm and cold, when you put the hands into warm or cool bucket, what people feel. So this is the middle of the line, and you can see when you don't need the when you don't feel the warm and cool sensation, or you don't need the cooling or warming, then people actually adding the put the hand in warm and cold water, actually their pleasant sensation was lowered. Only when they need that cooling or heating, then they feel higher pleasant. So I always give an example like when you are thirsty or when you are hungry. When you are thirsty, you drink water. Water tastes so sweet. You really appreciate the that water. But if you are thirsty, when you give food really doesn't create that pleasant sensation. So pleasant sensation is when external stimulus supply the things that you really required, you need. So here are two examples to show that creating this non-uniform environment sometimes have potential to activate a pleasant sensation. This is a Japanese hot spa in the winter, cold winter, that merge into water, make them hot, and came out of the water, feel the cool air, and merge again, actively create this sensation, transient sensation. And a person in the beach breathing to cool it, and then the sun warm the body, also create that pleasant sensation. That means this PECS system has a capability to create a non-uniform environment, a variable environment, to satisfy people's requirement. This is similar to the food, or I do watercolor. I like the watercolor. I like the purple color, but in the watercolor, you have this variation. The food also, even though certain things you like, you always want to have a variety. So the variation, that's PECS can provide this capability that has the potential to make people comfort and create a sensation, pleasant sensation. So that's the my presentation. Means PECS or PCS, we call PCS at UC-Berkeley. They are slightly different. We can explain in future. That has a potential to provide comfort and has a potential to save energy. Thank you very much.